For most of Earth's history, the oceans were filled with creatures so large and fierce that life on land often seemed safer. But there was one brief moment, over 250 million years ago, when the opposite was true. In the lands of what we now call Russia and Africa, giant saber-toothed predators and terrifying amphibians roamed freely, making the surface of the Earth a dangerous place to be. Meanwhile, the seas, vast, deep, and quiet, offered an unexpected refuge. What caused this unusual reversal, and why did it only last for a short time? To understand, we need to go back to a world very different from our own. We're going to step back in time to the late Permian period, roughly 259 to 252 million years ago. This was a world unlike anything we know today. Most of the Earth's land was joined into a supercontinent called Pangaea, stretching across the equator, while enormous oceans, including the vast Panthalassa, covered much of the planet. The climate was harsh, with scorching deserts and extreme temperatures shaping where life could survive. In this video, we'll explore why, during this unusual moment in Earth's history, life in the water was actually safer than life on land. We'll look at the predators that dominated the continents, the strange and fragile marine creatures that inhabited the oceans, and the forces that made survival on land so deadly. We'll also examine the geography that set the stage for this reversal and how it all led to one of the most catastrophic events in Earth's history, the Great Extinction that reshaped life forever. To begin understanding this remarkable world, we first need to look at the layout of the land and seas themselves. Around 259 million years ago, the Earth looked very different from today. Almost all of the continents were fused together into a single massive landmass called Pangaea, stretching from the northern to the southern hemisphere. This supercontinent created vast interior regions far from the moderating effects of the sea, where temperatures could soar to extreme highs. To the west of Pangaea lay the enormous Panthalassa Ocean, covering more than 60% of the planet's surface, roughly twice the size of our modern Pacific Ocean. Smaller oceans, such as the Tethys and Paleotethys, separated islands like what we now know as South China, Siberia, and parts of Turkey and Iran. Days were shorter than they are today, lasting around 22 hours because the moon orbited closer to the Earth. The equatorial regions of Pangaea were dominated by vast deserts, with intense heat and almost no vegetation, while mountain ranges, like the central Pangaean Mountains, created dry rain shadows and added to the extreme conditions. These factors combined to make much of the land inhospitable, concentrating life into smaller, more habitable regions across Africa, Russia, and scattered islands in Asia. This geography had a profound impact on life. On land, predators could dominate the concentrated populations of prey, leading to enormous, dangerous hunters that ruled the continents. In contrast, the oceans were relatively empty, with fewer large predators and more space for smaller marine life to survive. The layout of the land and sea set the stage for a rare and remarkable reversal in the natural order, where swimming offered a safer refuge than walking. To understand why this happened, we first need to look closely at the creatures that inhabited the oceans during this time. The oceans of the late Permian, while vast and deep, were surprisingly calm compared to the dangerous lands of Pangaea. Life beneath the waves was present, but it was far from the nightmarish scenes we often imagine when we think of prehistoric seas. Sharks, such as the hybodonts, were swimming in these waters. Unlike the giant, terrifying sharks of earlier periods, these sharks were relatively small, usually only about 2 meters long, roughly the size of a modern leopard shark. Their teeth were designed for soft prey like squid and small fish, not for tearing through large armored animals. Alongside them, remnants of older marine lineages still persisted. Trilobites, once diverse and dominant hundreds of millions of years earlier, were now reduced in number and variety, living mostly in the shallower parts of the seas. Ammonoids, distant relatives of modern squids and octopuses, drifted through the water with coiled shells, but most species were small and posed little threat to anything else in their environment. Even the eurypterids, often called sea scorpions, were a shadow of their former selves. Once enormous and formidable, by this time they were mostly small, struggling to survive after earlier extinction events. This unusual calm in the oceans was the result of a recent global crisis, the Capetanian extinction, which occurred around 262 million years ago. This event had devastated marine ecosystems worldwide, wiping out large numbers of species and leaving the seas sparsely populated. As a result, the oceans during the late Permian were filled with smaller, less aggressive creatures, and there were almost no large predators to threaten life below the waves. For anyone living at the time, swimming in these waters would have been far safer than walking on the continents, where gigantic predators were already beginning to emerge. Yet, even as the seas offered a rare refuge, this balance was delicate, and the story of life on land was only just beginning to unfold. The contrast between the quiet oceans and the dangerous continents sets the stage for an astonishing chapter in Earth's history, where survival on land became a constant struggle. While the oceans were unusually calm, the lands of the late Permian were anything but safe. The continents of Pangaea were dominated by some of the most fearsome terrestrial predators the Earth had ever seen. Among the most notorious were the Gorgonopsids, a group of saber-toothed hunters that evolved around 265 million years ago and became apex predators across much of the supercontinent. These were not mammals, but therasids, closely related to the ancestors of mammals, yet they carried long, narrow skulls and terrifying serrated canines that could slice through flesh with ease. Their bodies were strong, built for both speed and power, allowing them to hunt efficiently across the harsh landscapes of Russia, Africa, and parts of Asia. The largest and most famous Gorgonopsid was Inostrandsia, found in what is now Russia. Adults could reach over 3.5 meters in length, weighing more than 450 kilograms. Its elongated skull and enormous upper canines, sometimes measuring 6 inches long, made it one of the deadliest predators of its time. Inostrandsia was not only large, but also agile, with long, sturdy limbs that allowed it to chase down prey over open plains and through sparse forests. Its hunting strategy likely involved targeting medium to large herbivores, delivering precise and lethal bites designed to incapacitate its victims quickly, a combination of strength, speed, and specialized anatomy that made it a top predator. In Africa, Gorgonopsids were equally dominant, with a subgroup called rubigenes. These predators were slightly different, with thicker skulls and heavily serrated teeth designed for cutting through tough hides. Some species, such as Rubigia atrox, grew close in size to Inostrandsia, reaching length of up to 3 meters. Fossils suggest that these animals often shared their habitats with other large predators, hinting at frequent competition and a complex ecosystem where survival required both skill and aggression. Alongside the Gorgonopsids, another group of predators added to the danger, the Therocephalians. These animals were generally smaller than the largest Gorgonopsids, but were highly diverse and widespread, ranging across Russia, Africa, and China. Some may have even been venomous, possibly the first tetrapods to evolve venom, which they could use to immobilize prey or defend against competitors. Others developed unusual hunting adaptations, including saber-like teeth or semi-aquatic lifestyles, which allowed them to exploit habitats that even the Gorgonopsids could not dominate. The threats did not end there. Mid-sized predators roamed the continents, hunting opportunistically or scavenging, while enormous amphibians like Prinosuchus lurked near rivers and swamps. Prinosuchus, sometimes over 9 meters long, could ambush anything that came close to the water's edge. Between the giant saber-tooths, venomous hunters, and massive amphibians, the late Permian landscapes were a patchwork of danger, where a single misstep could be fatal. This concentration of predators, combined with harsh climates and sparse safe habitats, made terrestrial life extraordinarily perilous. Every region of the supercontinent held its own unique dangers, and survival demanded constant vigilance. Yet while land was dominated by these fearsome creatures, the oceans remained calm, offering a rare and unexpected refuge. To understand why this contrast existed, we now need to explore the herbivores and other life forms that shared these deadly landscapes. But even this terrifying world on land was only part of the story. Over time, forces far beyond the predator's control were building, powerful changes that would sweep across the planet and reshape every ecosystem. Soon, Earth would face a catastrophe so vast that it would wipe out the majority of life, both on land and in the oceans. This was the Great Dying, the event that would change life on our planet forever, and its effects were more devastating than anything that had come before. While the predators of the late Permian were terrifying, the herbivores that shared the continents were far from defenseless. Across Pangaea, from what is now Russia and Africa to scattered regions of Asia, a variety of plant-eating animals had evolved remarkable adaptations to survive in a world filled with enormous threats. Among the most famous were the dicynodonts, with Lystrosaurus being the standout genus. Lystrosaurus was roughly the size of a pig or badger and had a barrel-shaped body with strong limbs built for digging. Its tusks, while small, allowed it to root through soil to reach roots and tubers, giving it both food and shelter. Fossil evidence suggests that Lystrosaurus may have dug burrows, providing protection from the constant threat of predators like gorgonopsids and thermocephalians. Another striking group of herbivores were the parasaurs, such as Scutosaurus, which were enormous, heavily armored reptiles. Some individuals weighed over a ton and measured several meters in length. Their bodies were covered with thick, bony plates embedded in the skin, and many had spikes on their skulls or along their backs. These adaptations served as formidable defenses against even the largest predators of the time, making it difficult for a gorgonopsid or rubigian to inflict serious damage. Scutosaurus and its relatives were slow-moving, but their sheer size and armor made them challenging targets, while their herbivorous diet allowed them to survive in regions where vegetation was sparse but still sufficient. These herbivores were more than just prey. They played a crucial role in the late Permian ecosystems. By grazing and foraging, dicynodonts, parasaurs, and other plant eaters helped shape the landscape, distributing seeds and influencing plant growth. Their presence created a dynamic balance where predators had to constantly adapt and hunt strategically to survive, while herbivores relied on their digging skills, armor, tusks, and spikes to evade death. Fossils of these herbivores have been found across vast stretches of Pangaea, indicating that these survival strategies were effective in multiple regions, from arid deserts to more vegetated floodplains. Despite these adaptations, life on land remained precarious. Every herbivore had to navigate a world filled with large, fast, and cunning predators, and survival often depended on both physical defenses and behavioral strategies. As we explore the ecosystems of the late Permian further, it becomes clear that the balance between predator and prey was intricate and delicate, setting the stage for the planet-altering events that would soon follow. The next step is to look at the skies and waters themselves, where life took a very different and much safer path. Above the dangerous landscapes of the late Permian, the skies were surprisingly quiet. Unlike the Mesozoic, which would later be filled with enormous flying reptiles capable of hunting on land, the late Permian skies were home to relatively small and harmless aerial creatures. Griffinflies, ancient relatives of dragonflies, drifted through the air with wingspans that could reach up to half a meter, but they posed no threat to the larger animals below. Other gliding reptiles, like members of the Wygoltosauridae family, moved between trees using specialized membranes to glide from branch to branch, but even the largest of these were no larger than a modern bat. Flying predators that could take down sizable herbivores simply did not exist at this time. The air offered a refuge of sorts, a space where animals could move without fearing the massive gorgonopsids or rubigines that dominated the ground. While griffinflies and gliders might have been a nuisance to insects or small prey, for most late Permian creatures, the skies were a place of relative safety and calm. This contrast highlights just how deadly life on land had become. On the ground, predators roamed relentlessly, while in the air, the dangers were minimal. As we continue, the story of survival on Earth takes an even darker turn, moving toward the catastrophic event that would soon reshape the entire planet. About 252 million years ago, the late Permian world, already dominated by relentless predators on land, faced a catastrophe unlike anything seen before or since. This event, now known as the Great Dying, marked the largest mass extinction in Earth's history. It was a time when the balance of life on the planet was utterly shattered, and nearly every ecosystem was pushed to the brink of collapse. The cause of this global disaster lay in the massive volcanic eruptions that created the Siberian Traps, an enormous region of volcanic rock in what is now Siberia. These eruptions released staggering amounts of carbon dioxide and sulfur gases into the atmosphere, triggering a chain reaction of environmental crises. Temperatures soared, sometimes reaching levels comparable to the hottest regions on Earth today, while toxic gases created severe hypoxia, low oxygen conditions, that made survival difficult for most animals. Oceans absorbed much of the carbon dioxide, leading to acidification that decimated marine life and disrupted the food chain. The consequences were catastrophic. Scientists estimate that around 57% of all biological families and 83% of all genera went extinct. On land, the predators and herbivores that had dominated Pangaea were nearly wiped out. Entire groups of gorgonopsids, therasids, and other dominant species disappeared forever. In the oceans, the extinction was even more severe. Though the waters had previously offered a refuge from the relentless predators on land, the warming, acidified seas became deadly as well, wiping out trilobites, ammonoids, and many other marine animals. There is a stark irony in this period of history. For millions of years, land had been the most dangerous place to be, while the oceans were relatively safe and calm. Yet, during the Great Dying, that relative safety vanished. Even the oceans, once a sanctuary from the terror of giant predators, could no longer protect life from the overwhelming forces of volcanic activity, climate change, and environmental collapse. As the late Permian came to a close, the world that had once been dominated by saber-toothed hunters, massive amphibians, and heavily armored herbivores was transformed. Life had survived, but only in scattered pockets, and the stage was set for a new era of evolution. This moment of destruction reminds us how fragile ecosystems can be when natural forces act on a global scale, and sets the stage for the dramatic changes that would follow in the Triassic. For a brief window in Earth's history, roughly 259 to 252 million years ago, the usual rules of survival were reversed. While the oceans were calm and relatively safe, the land was dominated by formidable predators like gorgonopsids and therocephalians, alongside giant amphibians and other relentless hunters. Herbivores like Lystrosaurus and Scutosaurus relied on armor, digging, and tusks to survive, but even they faced constant danger. Then, with the onset of the Great Dying and the volcanic eruptions of the Siberian Traps, both land and sea were reshaped, leaving vast portions of life extinct and opening the door for entirely new ecosystems. This unique moment in the late Permian reminds us of the fragile balance of life on our planet. For a brief period, the safest place to be wasn't on solid ground, it was in the water, drifting among the calm seas of an ancient world that had turned the rules of nature upside down. If this glimpse into a prehistoric world captured your curiosity, take a moment to subscribe and join us as we explore more chapters of Earth's incredible history. Like this video if you enjoyed the journey, and share it with others who love uncovering the mysteries of our planet's past. Each view helps bring these stories to life and keeps the adventure going.